Okay, good morning again, Cappuccino. I had some questions. Some people turned in their work from this investigation, and some people asked me questions. They got stumped. So I wanted to talk about it a little bit, but really the idea of this was that you just try your darndest and see what happens. And if you get stuck, well, you try and work past that, okay? What are you going to do when you're in college and you have nobody to ask, okay? You got to figure it out. Or just do the best you can and keep going. Okay, so in this investigation, what they were doing is they were saying if we couldn't use the integration tool on our calculator, if we couldn't integrate, how could we find the area underneath a curve? And the idea is that you can actually break the area up into trapezoids. So we did this before when we first learned about integrals. So we broke it into rectangles. So we made a rectangle that was too big and a rectangle that was too small, and then we averaged them out. This is basically doing the same thing, except that it's doing it with fewer steps. So we're just doing it with finding area of trapezoids rather than with finding area of rectangles. So this is part of the HL curriculum that my juniors will need to have mastered by next year. But really what it is it's being able to take an idea and come up with your own formula to represent an idea. So they showed you on this one that you're breaking up the area into 4 trapezoids, and it says let the width of each trapezoid be h. Okay, so this distance from here to here is h. And the lengths of the parallel sides are going to be y sub 0, y sub 1, etc. So this height right here would be y sub 0. This height would be y sub 1. This height would be y sub 2, y sub 3, y sub 4. So then they want you to write down an expression of the area of each trapezoid. So taking one trapezoid at a time, write them down, and then you should be able to simplify it to this. So this is an exercise in algebraic manipulation. This first trapezoid, if I write down its area using the trapezoid formula, it's 1/2 height times the 2 bases. The 2 bases in this case are y sub 0, and the next one would be y sub 1. So it sometimes helps to turn it on its side. If you turn it on its side, here's the base, here's the base, here's the height. Okay, so maybe it's a little confusing having the trapezoids standing upright. Okay, so then I would continue and I'd do that for the next 3 trapezoids and add them together, and then you want to factor. You want to see what do these have in common and factorize it as much as possible, and when you do that, you'll end up with this. Okay, so then it says, well, what if you don't know how many trapezoids there are? There's n number of trapezoids. What would this look like? Okay, so it would pretty much look the same as this. The nth trapezoid, see how here there's 1, 2, 3, 4 trapezoids, and the last y was y sub 4? So the last y is going to be y sub n. And then notice in here, the first y and the last y only appear once. They only get used once. And all the other y's in here, they get used twice. So if we write this out, okay, well, it's going to be pretty much the same as this. It's going to be 1/2 the height. And we're going to talk later about how do you actually get the height. 1/2 the height times the first y value plus the last y value. And then 2 times all the y values in between. Well, how do you write that? Okay, so it would be y sub 1 plus y sub 2, and then you'd say plus ... bunch of y's, and the last y in here would be, what would be the last y that you would have to add in here? I can't say 3, because that would imply that the last one would be 4. So how would I say this one? Well, if the last one is y sub n, what's the one right before y sub n? It would be y sub n minus 1. That would be the last one inside your parentheses. Okay, so you're allowed to do a little ... to imply that you're adding all those y values in between y sub 1 and y sub n minus 1. We can just put a ... to represent that. Okay, so that is the answer for this, and that's actually the formula we're going to be using for today's assignment in math space. Okay, next here, this question here, use your graphing display calculator to get the area. We actually did that on our warm-up. That answer was 21.5, but they went it to 2 decimal places, so it would be 21.50. And then you're going to calculate the area, area of each of these trapezoids. Okay, so how do we get the H? How do we find the value of H? So if we, where do we have it? Let's use it to approximate. Where did we ask that? Oh, here it is. Sorry, I have it on this side because this is before I rearranged the paper for you. Find the width H of each trapezoid. So if I want to know how wide each of these trapezoids are, well, let's think about this. I'm starting at 1, and I'm ending at 6. So what's the total distance here? To get the total distance, it would be 6 minus 1. And then I want to divide that into 5 pieces. Oh, I want to divide that into 5 pieces. So what's the width of each one of these? 6 minus 1 is 5. 5 divided by 5 is equal to 1. So the width of each piece, so that was the answer to B. The width, or we're calling that H, of the trapezoid is 1. So same thing here for finding the value of H if there's 10 trapezoids. Again, I'm starting at 1 and I'm ending at 6, but I'm going to divide it into 10 trapezoids. So I would have 5 divided by 10. Well, each of those are going to be half a unit wide, or the H is equal to 1/2. All right? And then you are going to use your calculator to figure out what are the heights or the lengths of each of the bases. Okay, you're going to use your calculator to figure that out. What was handy on this is using, like I used an XY table. I made a little XY table. So what is when X is 1? When X is 1, what's the height? What's Y? It would be 12 divided by 1, which is 12. And then if I'm going by 1/2, well, 1.5. Well, then I'd have to do 12 divided by 1.5. And I actually used my calculator to figure these out. Okay, and then I would have to do 2. And so I'd have 12 divided by 2 is 6. And then I'd do 2.5. Okay, so I made a table to help me stay organized for this. I told you to look up how to find percentage error for this approximation. So if you go to Google and just put in how to calculate percentage error, you'll find a formula for that. Okay, and then the last 2 questions. Conceptual, how can we estimate the area under a curve? What they're asking you is to just summarize, what did we just do? How can we estimate? This is an estimate. It's not an exact answer. It's an estimate. As you can see by when you find the percentage error, you get really close to the actual area. So you need to summarize this. Don't go off and come up with other ideas. You're just supposed to be summarizing what did we just do. How can we do an estimate of an area under a curve? What did you just learn? And how do you get closer and closer to the best answer? So from what you just learned, what's the best way to make your answer even more accurate? Okay? Now, what we're doing today is we're going to do the same thing. We are going to be doing problems using this trapezoidal rule. Here is the rule that we discovered on question 2. This is what you should have ended up with. And here's how we calculate H. So B and A, B was here, that's the 6. A was the 1. And then N is the number of trapezoids, 1, 2, 3, 4, 5 in this case, or when we did it with 10 trapezoids, N would have been 10. Okay, so it's your last, this is your last X value, and this is your first X value. So you subtract those and divide by how many trapezoids you want. All right, so this method is particularly useful when values on a curve are known, but not the function that defines the curve. So I am giving you this example to look at. And notice we have the contours of a river valley. Yes, cross-section of a river, sorry. That's cross-section of a river. And we're trying to find the volume of water that is passing past a point. Okay, so we need to figure out what the area is. To figure out the volume, we first need to figure out the area. So that's what's going on here. So I'll let you read through that, and then these are the type of questions you're going to be doing in math space. Okay, so as for math space, I told you in my announcements that I'm going to be doing bare minimum and then going all the way. So I expect everybody to do, in the math space assignment, I expect everybody to do 1 through 7. I actually put a total of 15 questions in here. So if you are going to be majoring in science or engineering next year in college, or if you're going, or if you're a junior, okay, so all juniors and anybody who's majoring in science or engineering should continue. So in other words, HL folks and all my STEM majors, you should be doing 1 through 15 in the math space. Okay, so 1 through 7. So this is my my liberal arts majors, only 1 through 7. If you're a STEM major or if you're a junior, you should be doing 1 through 15. Okay, on your mark, get set. Oh, by the way, you don't have to upload notes for me. Okay, these notes are just for you. If you want, you can paste them in your notebook or copy them into your notebook. You don't have to put the example, but do put the formula and this. So this you should put in your notes at the very least. If you do have a printer and you can print out this example, it would be nice to put the example in your notes also. But you do not need to upload your notes for me, okay? You're just going to do the math space assignment. All right, on your mark, get set, math.